this meant survey to you. Let me share it in the chat box. And request all of you to please answer these simple questions about structural equation modeling. And it's not about testing your expertise. It's about I want to know from where should we spend more time. So please take your time. Simple 3-4 questions, and recording the answers, and then we can discuss with you as well. So all of you have to use this link and then submit the answer, whatever according to your understanding is the best answer. It's a multiple choice survey. The results have started popping up. So let's see how many of you have already completed it. We are not having a lot many participants, so I think we can go over it very quickly. That's it. I think we are having 4 or 5 participants, and we have already got the results. You guys are able to see the results. Let me just broaden the view for you. How much do you know about structured equation modeling? This is the first question, and some people, they know a little bit, and while others said that they know very little about it, or probably absolutely nothing. They said, which one is a superior technique? This goes, both are equally good, and majority of the participants said depends on your research objective. Which variance-based PLS technique, which is the variance-based PLS technique of Amos, or as we popularly call it, AMOS, Smart PLS, MPLS, all are techniques. In a little while, we'll get to know what this VB and CB techniques are, what is the difference between them. By the way, the answer to this question, variance-based technique, AMOS is covariance-based, M plus covariance-based, Smart PLS is the right answer. And how is your experience with the result? So that's it. So the thing is, as I make my assumptions, or as I get to know that it's the divided opinion. Some people know thing and some people absolutely know nothing. So we will try to first discuss the concepts in detail, hopefully, inshallah, and then practice it using that PLS-2. Let me switch to the presentation. Yeah. Uh, let's start with this. You are able to see a scary picture which shows you some oval shapes and some arrows from here and there. But if you don't know what structural equation modeling is, you must be knowing what a dependent variable and an independent variable is. I know. So for this, before we move on, the purchase likelihood here, all the arrows are primarily wherever it is start, wherever it is ending, but the ultimate outcome variable per likelihood. So that is going to be the dependent variable. So here are some variables which are intermittent as well, though it means they are the intermediate variables or intermediary variables, which we popularly call, or which are better known as the mediating variables. Advertising budget, experience, risk are some of the IVs or independent variables. In between are two variables, brand attitudes, information search. And you can see that brand attitude, on the left of brand attitude, there are three variables or three constructs upon which the arrows start. The advertising budget has some influence on brand attitude. Experience also has got some influence, as our hypothesis, as we assume in our information search is there. So this shows that for a single variable, which is brand attitude, we have three dependent variables or three confounding variables, you can say. Confounding variables, we don't need to call them confounding variables because they are out of the model. Confounding is something which can have an effect other than these variables. So for this variable, which is brand attitude, there are three variables which have an effect. And if you see at the information search, again, there are two variables. One is experience and one is risk. And then brand attitude also is having a relation from the information search. And ultimately, brand attitude and information, they land on to purchase likelihood. So if you count in total, we have almost 1, 2, 3, 4, about 9 arrows which are from the left side to the right side. And the ultimate outcome variable is purchase likelihood. So primarily of the structure equation modeling, so 2, 3 things just to bear in mind. This is a multivariable or multivariate technique. And it's not the simple technique. From this simple model, this is a simpler model. I warn you, this is not to make you people scary or make you people afraid of it. But if you see modeling with all the arrows and with all the constructs in there, you will probably unable to count the arrows in. It means the model is relatively complex. There are relations here and there. In between, there could be intermediate variables. There could be variables which can moderate the relationships between EVs. So two things. One is multiple variables are there, they have multiple relationships. A complex structure is out there. So that is structure equation modeling. And the model that we ultimately get is a structure and a relationship model, which we will discuss in about 10 to 15 minutes from now. Let's move on. This, as I earlier asked you, what is a covariance structure equation modeling and what is a variance-based structure equation modeling. Just give me a break and then we can continue. I mean, you can just read it out. Uh, Probably you have heard of this confirmatory factor analysis, and along with that goes the EFA, which is exploratory factor analysis. These two things make the wholesome MUS model or MOS model, which is also known as covariance-based structure equation modeling. Today we will discuss the PLS-SEM or structure equation modeling, which is variance-based structure equation modeling. So primarily, these two flavors, they are not. It's not a question of superiority of the technique. Both techniques are superior, both techniques, but which one to use at which time? As you people rightly put, that it depends on the research question and the objective. What about the model? What we need actually want to estimate out of these set of variables? That in the choice of the technique. Here, the Pandora box opens. The variance-based structure equation modeling, the whole objective of using the technique is to reproduce the theoretical covariance matrix without focusing on explained variance. Normally, if you talk about the grand equation or the explanatory power of a model, we are always interested to know what R square is. I think you all know what R square is. It is the explained variance out of a model. So that explained variance goes in the basis of this partial least square structure equation modeling. You can see the maximum. The purpose of using a model is on maximizing the explained variance of the endogenous latent constructs. Normally, we have a single outcome variable, so we are interested to plug in more variables. As was said, most of these variables are latent variables. The latent variables are constructs or concepts we cannot directly measure. We use items or we use indicators to measure that. And all those latent, they have a relationship with the dependent variable. The more we plug in those constructs, and if that R square keeps on maximizing or keeps on becoming higher and higher, this means our model robustness is increasing, our explanatory power is increasing. So that's the basic difference. Whereas the MOS or AMOS model, here in that model, there are certain error terms, and we are able to covariate those relationships as well. That is not the purpose of today's discussion. We'll keep it out. So let's focus on what PLS-SEM is all about. Another thing is, as I said, no technique is superior, but it only depends on what is purpose. Are you able to test a model Are you able to replicate? I mean, do you want to replicate something using a pre-tested set of constructs, or is it about new theory and testing new relationships, or you can say it's about devising a construct or devising a new theory. And for that theory, if you want to know what are the measurement items, so then the first technique, which is covariance-based structure equation modeling, that will be used. There are certain conditions that we need to follow, but let's move on to this. Please keep in mind these rules of thumb. Whether PLS-SEM is used or covariance-based SEM is used, if your goal is theory testing, or you want to confirm a theory, or probably comparison of alternative is the objective, then always MOS or covariance-based structure equation modeling will be your first choice. If the structure equation modeling has non-recursive relationships, this means if you are not sure whether there are established relationships or not, then again, please try to check it through covariance-based structure equation modeling. Or if your research has to follow a global goodness of fit criteria, which has been pre-established, given to you, because there is no single goodness criteria for the PLS-SEM, as there are different flavors. Smart PLS is there, bar PLS is there, PLS graph is there. So they probably provide their own set of goodness of measures, which are only applicable to that single technique. While if you are able to predict key target constructs, if there are formative, and if the structure equation model is complex, and to some extent, if the sample size is small, data normality is not there, then PLS structure equation modeling or the based structure equation modeling is preferred as the superior technique. So before we move on, I would like to know, are we able to keep up with these concepts? Because things probably would be kind of going more complex. So if there are any questions, we can discuss here. So if no questions, then probably we'll keep moving. Uh, it's a comparison from on the basis of studies that social sciences that are done in management sciences as well, and you can see the comparison of those studies where attribution modeling was used as the methodology, and the studies where no structure equation modeling was there. So if you compare, clearly you can see that structure equation modeling studies or the research that employed structure, they got a better results in terms of topic relevance, research methods, data analysis, concentration, writing quality. The mean score is higher. So it means that if these values are higher, so on the other side, when you are going to decide whether you will publish this study in your journal, editorial board member, probably as a reviewer, the clear choice or clear recommendation here is that go for structured question modeling. And I would like to caution you that it has also become a fashion now. People bring in structured question modeling even if there is no need. There is a very simple model, and still they want to use that structured question modeling. So there are pros and cons. Keep that in mind. This is another uh, diagram where you see oval shapes and rectangles. Let me tell you, the general diagrams, the concept or the concept, which is a latent variable, it is um, it is a pre-established. You draw it and you label it with certain arrows and the items of that construct, because here if you see y1 and y2 in the first block, they are being represented by x1, x2, x3, and x4, x5, x6 comes in for the construct which is y2. So it means that y1 and y2 here represents those latent variables, and for those latent variables are the indicators which we will use. And also, if you go to the right side block, shown as y3 and y4, and its own indicator. And there are certain error terms also, but these error terms are there only for MOS or for covariance based models that I told you. But today we will not discuss this, so you can omit that. If you closely see, you are able to understand that there are different types of models here. One is measurement model, and the other is structural model. Or you can also call the measurement model as the outer model. Two outer models. One is on the left and one is on the right. And the outer models, then further, they have their indicator items which are used to measure those latent variables. So these measurement items, this model is called as measurement model. So, or you can remember it, there are inner relationships from one construct to the other construct that will also that will always be called as inner model or structure model, because the structure is represented by the relationships between the latent variables, and wherever the indicator comes, wherever the items come, these indicators are and let me tell you what this indicator item is. Probably you have got some questionnaire in your mind, and that questionnaire is um, or let me show you one questionnaire. Just hold on. So this determinants of adoption of SaaS-based fintech services. Can please somebody respond in the chat that it is visible to you? Thanks, Faryal. So this will give a better idea. This is a published paper which talks about what are the factors that determine the adoption of SaaS-based fintech services. This mm, SaaS is software as a service, but without see a questionnaire with the demographic information that we collected. It's about gender, age, height, qualification, length of work experience, your employment level, then what is your role within the organization, some variables asking about the age of the organization itself, headcount, what is the primary sector, your city name. It depends on what is your requirement. Then comes these Likert scale items. Likert scale items are all about those indicator items that I told you. Here you see item number, serial number 12. Individuals whose opinions carry weight in our business also advocate for the use of SaaS solutions. This is the first indicator of a variable or a construct, which is SI. Then another item comes people who influence our business and IT tech stack think that we should use SaaS solutions. And I3 talks about another item, SI4 will come. Now this is PU. This is another variable. PU is perceived usefulness. Using SaaS-based financial solutions improve our business performance. So it means this PU will be measured by PU1, PU2, PU3, and PU4. PU5 is there. So these 5 indicators or these 5 questionnaire items, when you combine them, you get the result for one construct, which is perceived usefulness, which is one variable. And you just go through questionnaire, how many questions are there. Let's scroll down to the end. This is just to give you an idea how bigger and how complex the model can be. This simple model, there are 64 question is not a survey question. It's for mechanical. So 63 questions are there, apart from the 10 or 11 questions that cover the graph details. You see there are 60 questions or more than 60 questions. So, and number of variables you can identify. Some is being measured by 3 items, some is being measured by, some variables are being measured by 5 items. And we used only 5-point Likert scale. Normally people also use 7-point Likert scale or beyond as well. So this just gives you an idea how complex the model can be and how many interrelationships are there. So let's get back to this model. Here only 4 variables, y1, y2, y3, and 4, and which are being measured. So this is a very small, and that one that I showed you is an actually published paper, and it is much more complex. So this will give you an idea that the actual model in real life is going to be a bigger and more complex model. So that's why we use structured. And no doubt about that, if we want to measure it using I'm not going to get such robust results as we will get through this PLS-SEM. I already explained the structure model, the measurement model. Now let me talk about formative and excuse me. What are different types? Constructs can be reflective, constructs can be formative. And there are certain terms also which will be useful for you. Path models are there. I already explained indicators. I already explained paths are the arrows from IVs to DVs or probably the intermediary variables. So what is a reflective construct and what is a formative construct? So any idea? Can you people make use of chat box and write down what you think, what is the difference, what is a formative construct, what is a reflective construct? Nobody got an idea? Any guesses? What is direct and indirect? Uh, Pied Chaudhary Naman Majid Sahab saying it is direct, one is direct and the other is indirect. So, Mr. Numan, what is the meaning? What do you understand by the direct notion? Can you please write it down again? Okay. Informative constructs, different indicators combine to make that latent variable. So direct means the independent variables have effect on independent variables. Yeah, Priyal, you are absolutely right. Formative construct, uh, Faisal Adnan said, reflective constructs are measured by their indicator. Formative constructs are defined by the indicators collectively form the concept. Great. So most of the people have got their ideas right. So just view this diagram. A simple construct with the arrows outwards. And on the contrary, here is another construct. The indicators are inward. So in a sense, the construct is showing up something which is reflected through indicator 1, indicator 2, and then indicator 3. While here, like we have a relationship between two variables when one variable is having an effect. So in that sense, it in that sense that indicator 1 has something to do with this construct. It is actually explaining the construct itself. It is making some part in its explanation. You can just, although this concept is very, it's not the right, but just to give you the clarification for this right word, which where the arrows are inward, you can say that indicator 1 is actually forming the construct. So in total, this construct is by three indicators. So this will be the formative construct. We move on and we try to explain with an example. See, here is an example. Drunkenness is something which is a state. It's a latent variable and reflected through three different indicators. One is saying, I cannot walk a straight line because somebody is drunk. So this drunkenness is causing something which is visible, that that person is unable to walk a straight line. Then probably if you do a smell test, so alcohol smell will be there. And if you try to speak with him, that person will have a slurred speech. He will be slurry. So these three things indicate that the state of mind or the state of that person is he's drunk. So the arrow coming to show this. Wherever the other thing, what can cause a drunkenness? That person can consume a beer. Probably it is out of wine. Probably it is out of some other liquor. So you see, these are different sources which will actually create drunkenness. So the arrows are from the indicator to the construct. That's something which can explain what reflective and formative constructs are. This is another way construct domain. Construct is being formed by the indicators. Then you can see this big box and all the indicators are there. So the formative measurement approach generally minimizes the overlap between complementary. Reflective measurement is the commonality between the three of them. So please bear in mind, whereas whenever the reflective indicators there, they would represent one and the same thing and they are interchangeable. For example, if I say a construct that I like the use of technology. So whenever I like the use of technology, what I will do, I would use it repeatedly. This is an indicator. I would recommend it to my friends or to my friend circle. This is another indicator. And three, probably I would go on exploring new forms of technologies. So these three things indicate that I am fond of new technologies. So here, these three indicators would be of reflective nature. They would essentially be interchangeable. If you remove this indicator, it is not going to affect the construct that much. But this gets reversed for the formative construct. For formative construct, if you remove any indicator, this will remove a part of that construct. So it means the formation would be probably incomplete. It depends on how much that single formative indicator takes part in forming that construct. So it's very simple. Let's move on. Let's see if we try to measure the satisfaction with hotels. These red arrows show something, and then these pink or light, you can say, arrows show something else. Let's talk about first the red arrows. The red arrows, taking everything into account, I'm satisfied with this hotel. Another item says, I appreciate this hotel. Then comes, I am looking forward to staying night in this hotel. And then I am comfortable with this hotel. So you see, the arrows are outward. They are indicating my level of satisfaction. Even if you drop one item, it is not going to affect the satisfaction level much. But just make a comparison with these pink arrows. The room furnishings are good, the recreation offerings are good, the rooms are clean, the hotel is low priced. You see, different levels, you see different aspects of the satisfaction. For example, if you take out the pricing level, if this question is not there and somebody is trying to measure the satisfaction who is price focused, then this part will be omitted. Some other guest who is fond of the cleanliness, or probably who is more focused on the cleanliness of the hotel, and if this indicator item is not there, then he would worry whether how would I get satisfaction. So now you see clearly the formative constructs are different, and you want to keep all formats there, because without a single formative construct, some part of the construct will be affected. But for the reflectors, it's not the case. You can easily omit, and that's what we do when we go with the CFA. And if the um, structure loadings are there, if the pattern loadings are there, and if any indicator item loading, we can easily omit that, provided if the items that you are using, if the indicators that you are using, they are of reflective nature. So how about taking a 5 minutes break, and then probably we can jump on to our exercise. Meanwhile, I would also be sharing the test bench data with you people. let's resume. So now we quickly sample size. Uh, we have already discussed PLS structure equation modeling is an advanced tool, and the formative constructs are there and the reflective constructs are there. But the thing is, how many components you need to choose to get to that level of accuracy? You want to improve the R square, you want to add as many constructs so that the R square can be improved. But if the R square needs to be improved, if the constructs are there, so there should be a rule of thumb. And that rule of thumb says that if you have the maximum number of constructs, for example, if the maximum number of constructs are 10, then the rule of thumb says that you multiply the largest formative indicators with 10, which are being used to measure a single construct, or 10 times the largest number of structural paths directed at a particular latent construct in the structural model. Please note that whichever is higher, you need to get that number of respondents for your survey, because the more you get the respondents, the activity will be there, the level of confidence would increase with that. So now let's quickly start our PLS tool. This PLS screen, I I think it's visible to all of you. Let me first share the data file with you people.
डॉक्टर साहब एक क्वेश्चन है कि कैन PLS-SEM be applied on secondary data? Are presence of constructs necessary? What if we don't have latent variables, and what if there are no constructs?
So these are multiple questions. So let me answer them one by one. The first question is whether we can use advanced level or secondary level or even tertiary level models. Yes, of course we can, because this is the basic thing that makes PLS-SEM workable. Whatever independent constructs are there, you employ that as first level model, and then by designing a next level, a secondary level out of those constructs or those items, because in the higher level or in the higher order models, those constructs become the independent items, and those items serve into making another variable, which is a higher level variable. So it is very much possible. You can use it for individuals data, and then up to individuals, organizations data, countries data. So PLS-SEM can be used for higher order models as well. So the next question, ma'am.
The next question is, are presence of construct necessary?
Uh, well, I didn't get this question. Are presence of constructs necessary? Definitely, you have something to measure to get the information from one side. Asking about that all DVs are there or all IVs are there? The question is not clear.
The next question is, what if we don't have latent variables?
If we don't have latent variables, we have the variables which are dichotomous variables like yes or no. We can have continuous variables. Yes, we employ them. We employ the control variables in, and that control variables can be your age, it can be your qualification. Categorical data is there, dichotomous data is there. So very much can buy that.
So in अदर वर्ड्स, हम जो सेम है वो लगा सकते हैं अगर हमारे पास लेटेंट वेरिएबल है, तो फिर तो बहुत ही अच्छा। अगर नहीं भी है और खाली ऑब्जर्व वेरिएबल्स हैं, इवन इन दैट केस यू कैन गो फॉर सेम।
जी जी, बिल्कुल बिल्कुल मैम, यूज किया जा सकता है।
और इसी तरह से मैं अगर ऐड करूँ, जो आपका पहला क्वेश्चन था कि कैन PLS-SEM बी अप्लाइड ऑन सेकेंडरी डाटा, जैसे सर ने बताया, PLS-SEM जो सेम है बेसिकली वो आप सेकेंडरी डाटा पे भी लगा सकते हैं, प्राइमरी डाटा पे भी लगा सकते हैं, आप सर्वे डाटा पे भी लगा सकते हैं, आप टाइम सीरीज में भी लगा सकते हैं, पैनल पे भी लगा सकते हैं। सर प्लीज करेक्ट मी इफ आई एम रॉन्ग इन आंसरिंग टू एनी ऑफ द क्वेश्चन। व्हाट
मैम, ये जो आप पैनल डेटा और ये बता रही हैं, देखिए उसमें जो इकोनोमेट्रिक्स की टेक्चर है ना, वो हम यूज जरूर कर सकते हैं, बट वी नीड टू बिल्ड अ स्ट्रक्चरल मॉडल।
बिल्कुल
हमारे उस मॉडल के अंदर कहीं इंडिपेंडेंट वेरिएबल्स का कॉन्सेप्ट तो वहां भी होगा, तो वी कैन
बिल्कुल
वेरी मच एम्प्लॉय दैट।
बिल्कुल। सो व्हाट इफ देयर आर नो कंस्ट्रक्ट्स? वो क्वेश्चन इन क्लियर नहीं है वो। आप, मेरा ख्याल है शायद आप पूछना ही चाह रही हैं कि अगर हमारे पास कंस्ट्रक्ट्स नहीं है तो फिर भी क्या हम लेटेंट वेरिएबल इस्तेमाल कर सकते हैं या नहीं। तो मेरा जहां तक नॉलेज है, बल्कि सर आप बताइए इसके ऊपर, मेरा ख्याल है फिर तो लेटेंट वेरिएबल बनेगा ही नहीं।
जी, लेटेंट वेरिएबल बेसिकली, जैसे आपने शुरू में भी एक्सप्लेन किया था कि लेटेंट वेरिएबल इज सम इज नॉट इजीली मेजरेबल डायरेक्टली। तो इसलिए हम इंडिकेटर्स लेके आते हैं। अगर लेटेंट वेरिएबल नहीं है तो एटलीस्ट ये तो हो सकता है कि किसी वेरिएबल की स्टेट और हम खुद ही बेस्ड ऑन द आउटकम कि जी वो आइदर इट इज यस और इट इज नो, या जैसे हम जेंडर वेरिएबल को देख लेते हैं, उसको हम मेल और फीमेल कर लेते हैं, तो हम उसकी उस स्टेट के ऊपर डिटरमिन कर सकते हैं। इफ द वेरिएबल इज नॉट देयर, इफ द कांस्टेंट्स आर देयर, देन द कांस्टेंट्स आर समथिंग which are to directly intervene, उनको हम कहीं ना कहीं दरमियान में यूज कर सकते हैं एज कंट्रोल वेरिएबल्स।
इसी तरह से एक्चुअली आजकल जो सेम यूज हो रहा है, अब वो ज्यादा मीडिएशन और मॉडरेशन के लिए यूज हो रहा है। बड़ी पॉपुलर जो एक वो चला हुआ है, ट्रेंड चला हुआ है कि आप मीडिएशन और मॉडरेशन भी देख सकते हैं, इसमें रिलेटेड भी देख सकते हैं। सो उस पर्सपेक्टिव में भी इंशाल्लाह हम लोग बात करेंगे। आई डोंट नो आज सर के एजेंडा पे है या नहीं है, तो इसके ऊपर इंशाल्लाह फ्यूचर में भी एक वर्कशॉप हो सकती है। जी सर, प्लीज कंटिन्यू।
जी मैम, मैं बस वो डेटा शेयर कर दूं, तो फिर इसको जल्दी से एक मॉडल बनाते हैं और थोड़ा सा एक बेसिक मॉडल ड्रॉ करके सारा उसको एक्सप्लेन करने की कोशिश करते हैं। मुझे थोड़ा सा टाइम दीजिएगा, मैं वो डेटा फाइल जो है ओपन कर लूँ।
सेम के अंदर
जी, मैं वो एक्सेल फाइल दे रहा हूँ।